Welcome to this explainer. You know, when we look up at the night sky, it's so easy to just see static pinpricks of light, right? But every single star has a story. Today, we're going to unpack how just one specific point of light carries this massive, unbelievable weight of history, language, and astronomy. It's literally shaped our understanding of the cosmos for millennia. Let's dive in.
We're actually going to start down here on Earth with a pretty surprising dictionary definition. If you look up the word Hamal, you won't find outer space at all. Instead, Hamal simply means a porter, a bearer, or a servant who carries heavy loads, a term used predominantly in Middle Eastern countries. It actually comes straight from the Arabic root hamalah, which literally just means to carry.
So that brings up a really fascinating question for us. Why is an everyday porter illuminating the night sky? Sitting about 65.8 light-years away from Earth, Hamal is actually the 50th brightest star we can see. It's got an apparent visual magnitude of 2.0, making it this prominent, shining beacon. So, how in the world did a term for carrying heavy physical burdens get attached to this distant light?
Section 1. The Cosmic Porter.
To figure this out, we've got to look back at how ancient astronomers mapped the sky. That earthly dictionary definition of a burden carrier contrasts brilliantly with its astronomical Arabic root. The name originally comes from the Arabic phrase Ras al-Hamal, which translates to the head of the ram. Over time, people just shortened it to Hummel. And it sits right there as the absolute brightest star in the constellation Aries, which of course is Latin for the ram. So, while down on Earth the word means carrying a physical load, up in the sky, Hummel is carrying the identity of the entire celestial ram, marking its head right at the eastern edge of the constellation.
Let's move into Section 2, an utterly normal star.
Looking at this through the lens of modern astronomy, this star serves as a remarkably reliable cosmic baseline. In fact, BBC Sky at Night magazine ironically describes Hamal as being, quote, utterly normal. Now I know, when we talk about giant stars, normal sounds kind of dull, right? We want the fireworks, we want black holes, supernovas, bizarre cosmic phenomena. But honestly, for an astronomer, an utterly normal star is a total dream. It's the steady, reliable foundation you need to measure everything else against.
The stats perfectly illustrate why this matters so much. Hamal is officially classified as a K2 3b Ca1 star. The 3I part, that just tells us it's a giant. And that K1 at the end means it has slightly weaker calcium lines in its spectrum. It burns at a surface temperature of 4,373 Kelvin, which surprisingly is actually cooler than our own sun, giving it this really beautiful orange hue. Its metallicity, basically the amount of stuff in it that isn't hydrogen or helium, is only about 60% of our sun's. But here's the real kicker. Because Hamal is so incredibly stable, since 1943, its precise spectrum has served as a crucial anchor point for astronomers to classify other stars across the entire galaxy. It's literally the gold standard of normal.
Which brings us to Section 3, Secrets of the Orange Giant. But, normal is totally relative. As we peel back the next layer, we see the massive physical scale this star actually carries. Sure, it's a standard for classification, but its physical presence is anything but average. Measurements from the Navy Precision Optical Interferometer revealed something pretty astonishing. This aging orange giant is roughly 15 times larger in diameter than our own sun. 15 times! And it's about 43% more massive. It's actually exhausted the supply of hydrogen at its core and has evolved into what astronomers call a red giant branch star. So it's just swelling up as it ages, expanding massively outward into space.
Because of all that expansion, it is radiating 91 times the luminosity of our sun across all wavelengths. That's a staggering amount of energy. And because it's so huge and bright, astronomers can actually measure its physical disk and observe this really cool optical effect called limb darkening at its edges. Basically, this is a phenomenon where the outer edges of the star look darker than the center. Why? Because when we look at the edges, we're actually peering through the cooler, higher layers of the star's atmosphere.
Moving on to Section 4. The Ram's Hidden Planet.
Just when you think you've got this normal giant figured out, it turns out it's carrying a massive secret in its orbit. Back in 2011, researchers at a South Korean observatory noticed something tugging on Hamal. They used the radial velocity method, which is basically just measuring the tiny wobbles of a star caused by the gravity of something orbiting it, and boom, they found an exoplanet. And it is an absolute unit. It's got a mass at least 1.8 times that of Jupiter. It orbits the star every 381 days at a distance of 1.2 astronomical units. So, our reliable, normal anchor point? It's actually the center of its very own planetary system, carrying this massive gas giant right along with it through the cosmos.
All right, Section 5, Keeper of the Ancient Equinox.
This all builds up to reveal Hamal's incredibly deep historical significance. You see, long before we had fancy telescopes, Hamal was carrying a totally different kind of weight for humanity. It was our ancient anchor for timekeeping. To really get this, we have to look at how Earth moves. Our planet has this very slow 26,000-year wobble on its axis. Astronomers call it the precession of the equinoxes. Because of that wobble, the backdrop of stars behind the sun during specific times of year gradually shifts. Think back 2 millennia ago, between 2000 and 100 BCE. If you could see the stars during the daytime on the exact day of the northern spring equinox, the sun would be perfectly lined up with Hamal and the constellation Aries. Hamal was literally the ultimate calendar marker, signaling the start of spring and renewal for our ancestors. But, thanks to that slow Earth wobble, the alignment shifted over time and Hamal was essentially forced into early retirement. Today, when the spring equinox hits, the sun actually aligns with the constellation Pisces.
But the lasting legacy of that ancient alignment? It is absolutely fascinating. In astronomy, the exact point in the sky during the spring equinox is used as the celestial prime meridian. Think of it as the cosmic equivalent of 0 degrees longitude and latitude on Earth. Now, even though this point has completely drifted out of Aries and into Pisces over the last 2,000 years, astronomers basically refuse to change the name. It is still universally called the first point of Aries. Hamal and its constellation are just forever immortalized as the foundational anchor of our celestial coordinate system. So the star's ancient legacy is quite literally carrying the weight of our modern maps of the universe.
So what's the big takeaway from all this? It's that absolutely nothing in space is static. Not even the fixed stars we rely on to map our entire sky. We started out with a word that just means a porter who carries heavy loads. And we've uncovered this brilliantly glowing giant that carries an exoplanet, serves as a crucial anchor for stellar classification, and literally holds the history of human timekeeping. But Earth is still wobbling. The sky is still changing. If the cosmic prime meridian has already left Aries, what star is going to carry the weight of guiding us next? Keep looking up, because the sky is always moving.